Namaste and a very good morning to all of you. My name is Mithun, and in today's video, we'll be talking about a decision tree model. Now, there are many decision tree models that we can build depending upon the criteria that you choose. Now, here I will be building an entropy-based decision tree model. But specifically, why decision tree model? And what are the advantages of building a decision tree model? A decision tree model is a supervised learning technique. Here we have a dependent variable as well as a set of independent variables. And there are 5 main advantages of building a decision tree model. First, it is very simple and easy to understand. Second, it's useful in data exploration. Third, when we build a decision tree model, less data cleaning is required. It is not easily influenced by the presence of outliers and missing values. Fourth, a decision tree can handle mixed data type. It can handle scale, nominal, as well as ordinal data type. Hence, data type is never a constraint with a decision tree model. Fifth, it is a non-parametric method of building models. What do I mean when I say non-parametric method? Here, we are not making any assumptions about the variable. We are not saying that the variable should follow a normal distribution. None of those assumptions are made, and therefore these are distribution-free tests. Simply put, this is a non-parametric approach towards model building. Now, how do we kickstart the process of decision tree model? Here I'm using Google Colab, but the same codes can be used in Jupyter Notebook as well. Let us begin by importing certain libraries. To import the library, I will be using 4 lines of code. And as you can see here, I will be importing Pandas. What is Pandas? Pandas is a library which helps us in data analysis. Specifically, it is used for data manipulation, data munging, and data wrangling. You can select only a few columns. You can select only a few rows. You can subset the rows. You can generate a sample. You can slice the data set. You can merge the data set. You can append the data set. There are a lot of interesting data manipulation techniques that you can perform using Pandas. More importantly, I'm using Pandas here to display the data set like a spreadsheet. So first line of code is about importing Pandas. There's a very useful library, which is called as the Scikit library. It's a very popular library and is widely used for machine learning models. It has a lot of functionalities that allows you to classify the model. You can use machine learning, you can use Scikit-learn to build a regression type of a model or a time series kind of a model. You can use unsupervised models using the Scikit-learn library. Now, I'm here going to use data sets which are inbuilt into Scikit-learn, and therefore I'm importing the data set, some of the data sets that are present in Scikit-learn. I will be specifically working on a data set which is called as the iris data set. And the third line is about importing tree, because I will be building a decision tree model in this video. The fourth line is important because we don't build a model on the entire data set. We like to split the data set. 80% will be used for training, 20 will be used for testing. The decision tree model will be built on the training data set. And once I get the results, I will be obtaining the predictions on the test data set. I will try to compare the results between the training and the test data set. If the results are consistent, then I will go ahead and say that this is a robust model. If not, it only means that the model is not robust. So the first 4 lines of code is a general procedure to import the necessary libraries for building different models. Once we have imported the necessary libraries, the next step is to load the data set. What is the data set that I will be working on? The data set that I will be working on is a data set which is called as the iris data set. But even before I run the second line of code, I like to execute the first line of code. It's a very simple function here. As you can see here, I'm just loading the data set and I'm storing it in an object which is called as iris data. If you want me to display the contents of the file, all that I need to do is type the file name and go ahead with the execution. What I'm able to see here is a lot of numbers. It's not very easy to interpret these numbers simply because there are no column headings. This is not a very convenient format for machine learning. Ideally speaking, if we have the data as a Pandas data frame, a Pandas data frame is simply like an Excel spreadsheet. It gives you an Excel spreadsheet like view. I like to have the data set like an Excel spreadsheet. Once we have the data set like an Excel spreadsheet, it becomes a lot easier for us to comprehend the contents of the file. Right now, if you ask me what is 5.1, what is 3.5, what is 1.4, what is 0.2, it is not very easy for us to interpret these numbers. This is a NumPy array. So we would like to convert this at some stage to a Pandas data frame. Just out of curiosity, I just wanted to display this data set, which is what you are able to see on the screen. Let me scroll down to the third step. Once we load the data set, what is the next activity that we will be doing? We would like to check the data type of iris data. Let me check the data type. I'm going to use a simple function called as type. Once I run the type on this particular data set, I am able to see what is the data type of the source file. Now, the next step would be to examine the keys that are present in the data set. What are some of the keys that are present in the data set? For this, I can run the keys of function. You can see here, there are many dictionary keys which are displayed like data, target, frame, target names, description, feature names, file name, and data module. Some of these dictionary keys I will be using to access the variables. I want to access the independent variables as well as the target variable here. Now, simply put, if you want to see the data, all that you need to do is type the file name and you can use the key .data. We have already seen that this is the data set in the earlier command. So let me remove the data key, and instead of data, I like to see the target. You can see here, mostly the first few values are 0. Then you can see a set of 1s, and lastly, you can see the set of 2s. 0 corresponds to the first flower. The code 1 corresponds to the second flower, and the code 2 corresponds to the third set of flower. If you want to display the target names, all that you need to do is you have to type target underscore names. You can see here, these are the 3 flowers, namely setosa, versicolor, and virginica. These are the 3 sets of flower which I would like to predict. So this is the label, setosa, versicolor, and virginica. If you want to see the actual codes, you can just simply type target. Further, you can also display the feature names as well as the module name. Let's proceed. What I'd like to do at this stage is collect all the independent variables, and I'd like to store it as an object. All the independent variables. So all that I need to do is I just need to run this command, and I will be able to store all the independent variables in the object iris int data. Now, this is a very crucial step, because now what I wish to do is convert the original data into a Pandas data frame. It's a very simple function, pd.dataframe. I'm going to pass the data set inside this. the pd.DataFrame will act on the object and give me a Pandas data frame. And then I will be displaying the first 5 rows. This is a lot easier. You can see here, the first row has values like 5.1, 3.5, 1.4, and 0.2. You can see the values of the second row, third row, fourth, and fifth. This is a lot easier to comprehend as compared to what we had earlier. This is not at all easy to process, not at all easy to understand. But when I convert the original data into a Pandas data frame, this is how it is appearing. Now, I'm still not very clear what is this 5.1, what is this 3.5, because the column heading is not displayed. So I would like to display the column heading. So at this stage, what I have is a Pandas data frame. The next step is to display the feature names in the data set. A feature name is just a fancy word for the column heading here. So once I type feature names, you can see all the features that are present for this data set. The first 2 variables are the sepal length and the sepal width. Both of them are measured in centimeters. The next 2 variables are nothing but the petal length and the petal width. If I scroll up, you can see here, there is no column heading here. I would like to label each of these columns as sepal length, sepal width, petal length, and petal width. It will be a lot easier for us to process the data that way. So going forward, let me create a list with the column names. So this is a list of the column names: sepal length, sepal width, petal length, and petal width. Now, let me use the head function. You can see here, the column heading is appearing. Earlier, how did I have the data set? If you see here, I had it as 0, 1, 2, 3. Now, I can clearly see that the first column is sepal length, second column is sepal width, third column is petal length, and the fourth column is petal width. So what is the first row? First row corresponds to a flower. The first flower has a sepal length of 5.1 centimeters. It has a sepal width of 3.5 centimeters. Its petal length is 1.4 centimeters, and the petal width is 0.2. So these 4 variables are my independent variables. Similarly, we can interpret the second, third, fourth, and fifth record. So you have the sepal length, sepal width, petal length, and petal width. So far, what we have done is nothing but data pre-processing. We have not yet come to machine learning as such. So even before machine learning, what I'd like to do is I'd like to split the data set. Let me take you back to the original code here. When I scroll up, you can see here, I had imported train_test_split. This is very, very important because as the name itself suggests, the base data I would like to split as training and testing. Once we split the base data as training and testing, the training data will be fed into the decision tree model. The decision tree algorithm will learn important characteristics of the data set, and it will spit out the predictions. I can either stop there or go ahead and score it on the test data set. Once I obtain the predictions for the test, I would like to examine what is the overall accuracy on the test data set. So we will be using the train_test_split functionality, which we had imported earlier. At this stage, you can see here, this is the functionality which I will be applying, train_test_split. I will be applying this function on the iris int data set. And once I apply this on the iris int data set, I like to split it up into 2 portions. 20% will be used for testing, 80% will be used for training the data set. You can see here, I have created 4 objects. One is all the independent variables for the training data set, all the independent variables for the test data set, thirdly, the dependent variable for the training data set, and the dependent variable for the test data set. So right now, how many objects do I have? I have 4 objects. I have iris int train, iris int test, iris dependent train, and iris dependent test. So as the name itself suggests, we are splitting the data set in such a way that we are obtaining 80%, and this 80% will be used for training. The remaining 20% will be used for testing. So far, we have only split the data set. We have not instantiated the decision tree model. In this stage, what I will be doing is I will be instantiating my decision tree model. You can see here tree.decision tree classifier. I am specifying the maximum depth as 4, and the criteria that I'll be using here is entropy measure. Simply put, in a layman's language, entropy, you can just understand it as a measure of disorderliness. We want to move from a state of disorderliness to a state of order. We want to move from a state of chaos to a state of orderliness. So entropy can be understood as a measure of disorderliness. Apart from entropy, you can also build a decision tree using other important measures like a chi-square, or you can use information gain, or you can use a Gini's measure as well. The maximum depth is 4. You can control this, you can vary these values and look at decision tree from multiple perspectives. I'm instantiating it and storing it as an object called DT at this stage. Let me proceed further to build a decision tree model. Very simple. I'm going to use a function. Python makes it very, very simple. dt.fit. This is the decision tree object. I'm going to use the fit function. I'll be using the independent variables which I had created at the earlier stage and the dependent variable to train my decision tree algorithm. Let me run this again. Fair enough. Now, let me move on to the next stage. I have at this stage fitted a decision tree model. I'd like to see some of the predictions that the decision tree model gives me. To see some of the predictions, all that you need to do is use the function .predict. Use the function predict on the iris int test data set. So these are the predictions that I'm getting. 210. 210, these are nothing but the different flowers that the decision tree model is predicting. I like to also summarize and visualize the entire decision tree model. So to summarize the entire decision tree model, I will need the help of a package which is called as Graphviz package. So let me just import this package which is called as Graphviz package. Once this Graphviz package is imported, we are good to go because this package helps me visualize the decision tree model. I repeat, this package helps me visualize the decision tree model. As you can see here, I'm specifying certain properties in the export_Graphviz functionality. So it will ask me for the feature names. It's also asking me for the class name, so on and so forth. I can just specify some of these values and store it as an object called as ._data. Once I am able to visualize the decision tree, we are good to go. We can visualize the decision tree model that we have built. How do we visualize the decision tree model? All that I need to do is run this function, which is called as graphviz.source. You can see here, this is the decision tree model that we have. You can see, if we scroll down, this is the decision tree model that we have. I like to scroll to the right side so that you can get a perspective of the entire decision tree. Because the maximum depth is 4, I think the tree is quite deep. You can go to the earlier stage and you can specify, let's say 2 or 3, then you will get a shallow tree. Let us just try to understand what this decision tree is telling us. You can see here, you had 39, 37, and 44. What is this 39, 37, and 44? This is nothing but the sample size of each of the flowers that you saw earlier. Now, out of the 4 variables that we had specified, namely petal width, petal length, sepal width, the decision tree model has identified that the first most important predictor to classify a flower as setosa or virginica or versicolor is petal width. So you can see here, if the petal width is less than 0.8 centimeter, it predicts for setosa. There are 39 flowers of setosa. All of these 39 flowers have a petal width of less than 0.8 centimeter. So next time your friend comes and gives you a flower, and all that you need to do is examine the petal width. If the petal width is less than 0.8 centimeters, straight away you can classify it as a setosa flower. Very simple. Looks like these flowers have a smaller petal width. The question is, you may turn around and ask me, what if the flower's petal width is not less than 0.8? What if the petal width is greater than 0.8? Now, this is a slightly tricky question, not so easy. I can't answer it based on one variable alone. I need to use multiple variables. Let's just look at this. If the petal width is less than 0.8, you would take this path and say it is setosa. If the petal width is greater than 0.8, then what we need to do is not just look at petal width, we need to look at other characteristics. Here, if the petal width is less than 1.75, which means it is greater than 0.8 centimeter, but less than 1.75, we need to look at the next best predictor, namely petal length. If the petal length is less than 4.95 and the petal width is less than 1.65, 34 such flowers have been identified as versicolor. So this characteristic corresponds to the versicolor. It is highlighted in green. Let me just read this again. Here, the petal width is greater than 0.8, but it is less than 1.75 centimeters. Please follow only the green notes because the green notes are versicolor. The blue ones are virginica. I'm just drawing your attention to only the green notes. If the petal width is less than 0.8, is not less than 0.8 because it's false. If the petal width is greater than 0.8 but less than 1.5 centimeter, and the petal length of the flower is less than 4.95, petal width is less than 1.65, it predicts for versicolor. Now here again you see, what if the petal width is greater than 1.65? Then you have one such flower which predicts for virginica. Now, if you scroll up, we saw here that the petal length is less than 4.95. There are a lot of flowers which may not have a petal length of less than 4.95, which may be greater than 4.95. Then you have to look at petal width. If the petal width is less than 1.55, then you have two such flowers and they predict for virginica. So this is how you can interpret some of the notes. Let me just interpret these notes. How do I trace the path? Here, the petal width is greater than 0.8. The petal width is not less than 1.5 centimeter. The petal length is not less than 4.85 centimeter. Then you will be able to obtain virginica flowers. So this decision tree is useful because it's a rule-based approach which helps me classify the outcome variable. And using a decision tree model, we have been able to identify specific rules and specific characteristics which help me predict the nature of the flower. So if it is less than some value, you get Setosa. If it is not less than 0.8, you have to scroll down. You'll be able to look at a series of variables, then classify versicolor flowers. Similarly, for another set of rules, you can get Virginica flowers. Here, I'm interested in classifying Virginica flowers, but in a real-time scenario, you can use the same methodology, same set of decision tree, same set of decision tree methods to classify high-risk customers and low-risk customers, whether a person will respond to a campaign or not. It's widely used even in the case of fraud detection. So this is how we were able to construct a decision tree model using Scikit-learn. We were able to download the iris dataset. We did a bit of pre-processing of the dataset. After pre-processing the dataset, we were able to label the columns, and then we split the dataset as training and test. 80% went into training and the remaining 20% went into test. We were able to use the Graphviz package to visualize the decision tree model. And all that we need to do is basically look at the direction. One set of nodes correspond to Setosa. And the beauty behind using a Graphviz package is that it highlights the nodes. As you can see here, Setosa has one particular color, versicolor has another color. All the green color nodes that you see are all predicting for versicolor. Then you have for Virginica a different set of color. This color contrast helps me identify which flower am I interested in. Because many times in a multi-class problem, and this is a multi-class problem, we have three colors, Setosa, Virginica, and versicolor. These are the three flowers. In a multi-class problem, you may not be interested in all the three classes. You may be interested in one of the three colors. So instead of looking at every node, you can specifically look at one node. For example, if you're interested in only versicolor, you can just trace the path of only the green color nodes. You can see here, this is the path for the green color nodes. You can again look at this particular node. This again corresponds to versicolor. Again, I have got one more node, which is a versicolor. The shade of green also tells me the sample size. Here you can see you have a lighter shade because we are able to predict for only 3 samples. I don't want such a small sample because this might potentially indicate overfitting problem as well. Darker the green color, I'm able to obtain a higher sample size. Lighter the green color, I'm able to obtain a smaller sample. So this is how you can use the Graphviz package to visualize the contents of the decision tree. If you have liked this video, I request you to subscribe to my channel. I request you to hit the like button and share my videos with your friends and relatives. Thank you very much for watching this video and have a great day.